Hey folks, we're going to do a really short lesson here to just review midpoint and length of a line segment. We're going to get started with midpoint. Given a line segment with endpoints x1, y1 and x2, y2, the midpoint is the following. We are going to have a coordinate as our midpoint, okay? And the midpoint is going to be exactly halfway in between the x and the y coordinate. So we're going to be taking the average of the coordinates themselves. So we're going to be doing x2 plus x1 over 2 and y2 plus y1 over 2. And that's how you find the exact halfway point between them. Let's just do a quick example here, okay? Find the midpoint between 4, 7 and 2, negative 9, okay? So I'm going to do the midpoint is going to be equal to 2 plus 4 over 2 and 7 minus 9 over 2. 2 plus 4 is 6, divided by 2 is 3. 7 minus 9 is negative 2, divided by 2 is negative 1. So the midpoint is at 3, negative 1. Let's find the midpoint between negative 3, 1 and negative 7, 4. My midpoint is going to be located at negative 7 plus 3. Remember, minus negative, or no, this should be minus. Negative 7 minus 3 divided by 2, comma, and then 1 plus 4 also divided by 2. Negative 7 minus 3 is negative 10. Negative 10 divided by 2 is negative 5, so we have negative 5 here. 1 plus 4 is 5. 5 divided by 2 doesn't give us a whole number, so I'm going to leave this as 5 over 2. You could approximate it at about 2.5. Okay? Nice and easy. Add the x's together, divide by 2, add the y's together, divide by 2, and you have your coordinate. Okay, let's look at a more complicated example here. The midpoint of a line segment AB is M at 2, 3. Where A, negative 4, 2, is one of the endpoints. Algebraically, determine the other endpoint B. Okay, so we recall from our formula, the x value of the midpoint is x2 plus x1 divided by 2. Just like the y value of the midpoint is going to be y2 plus y1 all divided by 2. Let's take a look here. So I know that A is negative 4, 2, and I don't know what B is. So for now, I'm going to have A is going to be my x1, my y1, and B is going to be my x2, y2. Okay, our midpoint is at 2, 3. Let's start by finding the x's. I know that x2 plus x1 divided by 2 must be equal to my midpoint, and my midpoint value for x is 2. I also know that the x value for A is negative 4, so I can go ahead and sub that in. I can say, well, x2 minus 4 divided by 2 has to be equal to 2. I'm going to multiply the 2 out to get rid of the denominator, so I have x2 minus 4 is equal to 4. Therefore, x2 must be equal to 8. So I have the x value of my midpoint. I'm going to do the exact same thing, but for my y value here. So I have y2 plus y1 divided by 2 must be equal to 3. I know my y value for my a coordinate. My y value is 2. So I can go ahead and substitute that in. I can say, well, y2 plus 2 divided by 2 must be equal to 3. I'm going to multiply the 2 to get rid of my denominator. y2 plus 2 is equal to 6. And I'm going to subtract 2 from both sides in order to get y2. y2 must be equal to 4. Okay, so I can confidently say now, I can say therefore point B is found at 8, 4. Okay, let's flip this over now and let's do some length practice. So given a line segment with endpoints x1, y1 and x2, y2, the length of that segment, and we draw from Pythagorean theorem here, okay? So the Pythagorean theorem, I'm just going to say that, I'll write this in orange, L, and we're definitely going to need a large square root sign. We're going to have x2 minus x1 all squared, so that is our run, and plus y2 minus y1. So we're using our Pythagorean theorem here to find the distance between each step along the way, okay? A vertical stretch. Let's do some practice here. Determine the distance of each line segment. Okay, I have my x1, y1, x2, y2. I'm going to go ahead and find my length. Length is going to be 10 minus 6 squared plus negative 5 minus 3 squared. 10 minus 6 is 4, squared is 16. Negative 5 minus 3 is negative 8, squared is 64. This is going to be equal to the square root of 16 plus 64, which is going to be the square root of 80. And if you have completed our optional lesson and you know how to reduce this, you can go ahead and do that, which gives you 4 root 5. Okay, if you didn't do this lesson, if you chose not to, that's okay. You would just leave it as a square root of 80. Let's look at another example here. Negative 2, 6, and 1, negative 3. My length is going to be equal to 1 plus 2 squared, because subtracting a negative is like adding a positive, plus negative 3 minus 6 squared. 1 plus 2 is 3, squared is 9, so that's the square root of 9. Negative 3 minus 6 is negative 9. Negative 9 squared is 81. So this is the square root of 90. And once again, super optionally, if you would like to change this into a more simplified form, if you know how to simplify your radicals, this is going to be the same thing as 3 root 10. Again, this is optional if you did that lesson. Let's look at a more complicated problem. 3 ships are located at P, negative 3, 5, Q, 3, negative 5, and R, 4, negative 1. If P sends out a distress signal, which ship is closer? Okay, so I know that I am looking for the distance from P to Q and to R, and I need to compare them to see which one is closer. Okay, so the very first thing I'm going to do is I'm going to determine the distance between P and Q. Okay, the distance between P and Q is going to be equal to, I'm going to let Q be my x2 or my second coordinate and P be my first coordinate. So this is going to be 3 plus 3 squared, because it would be 3 minus negative 3, so that's plus 3 squared, plus negative 5 minus 5 all squared. 3 plus 3 is 9 squared. Negative 5 minus 5 is negative 10 squared. So that's the square root of 81 plus 100, which is the square root of 181. I'm going to go ahead and now I'm going to do my second one between P and R. okay? This time that's going to be, I'm going to let r be my second coordinate, so it's going to be 4 plus 3, again because subtracting a negative is adding a positive, all squared, plus negative 1 minus 5 squared, which is the square root of 7 squared plus negative 6 squared, which is the square root of 49 plus 36. 49 plus 36 is the square root of 85. Okay, I can see right from here that the square root of 85 is a smaller number because it is a smaller number underneath my square root sign. If we wanted to approximate both of these terms, okay, the square root of 85 is about 9.23, and the square root of 181, is approximately 13.45. So I can see that the distance from P to R is much shorter, and therefore R is going to be the one who receives the distress signal. So I can say, therefore, R is closer and will receive the distress signal first. And that's that.